In this video, we are going to learn about inverse relations and how to find the inverse of a relation or a function. Inverse means that basically whatever was the domain now becomes the range, and whatever was the range becomes the domain. So what's happening is whatever the x values or the inputs were, that will now become the output or the y values. Whatever the y values were, would become the x values. So for example, in this case, this was you had 1x, you have 2z, and you have 3y. That was your original function. So the inverse, which is denoted by a -1 in the exponent, would become x1, z2, and y3. So please note, f of -1 does not equal 1 over f. Okay, we have learned in the past that like x to the -1 is 1 over x. Negative exponents means you flip. That does not work with a function. So these are not the same thing. F to the -1 does not mean that you flip the function. So to do a table, if you have a relation, the inverse relation, literally if you notice that whatever the x was now becomes the y, and whatever the y was becomes the x. They go in basically reverse order. On a graph, same thing would happen. So for example, if your point was -1, 0, then the new point would be 0. Then the new point would be 0, -1. You completely swap x's and y's. So if this is 3, 1, then it becomes 1, 3. If this is 5, 3, this becomes 3, 5. And if this is 6, -3, this becomes -3, 6. And then what is interesting is happening is this is a reflection across the line y equals x. If you notice, they are going to be the exact same distance from the line y equals x. It's a reverse. Not a reverse, it is a reflection across that line. And then you have other types of graphs. For example, this graph right here is going to be y equals x squared. This graph right here would be x equals y squared. Again, they reflect across the line y equals x. This dotted line, it is a reflection between those two functions. Now, one thing you do have to realize is that when you take the inverse of a function, it may or may not be a function for the answer. For example, meaning you have learned if you think about the fact that the vertical line test determines whether if a expression is a function. So if I was to draw vertical lines down here, this is a function. Vertical line test passes because it only crosses once. But the moment you take the inverse, if I was to draw vertical lines, it crosses more than one place. And so sometimes the inverse is not a function. So in this case, this inverse is not a function. Domain and range also flip. So for example, the domain of this function was all real numbers because it goes forever left and it goes forever right. The range starts at 3 and goes up. That's the domain and range. the inverse of that, this domain now starts at 3 and only goes to the left, but the range goes forever up and forever down. The domain and range completely swap places. And now to physically take the domain or range of a function, what you're going to do is you first swap the variables. Wherever you had x, you're going to put a y. Wherever you have y, you're going to put an x. Physically swap those variables. And then now solve for y. So to solve for y, I'm going to add 8. And then I'm going to divide by 2. So I'll get x plus 8 divided by 2 equals y. Or you could even say 1/2 x plus 4. These are the same thing. Just know that if you break this fraction, make sure that the 2's gets broken to both parts of the numerator. That's why x over 2 would become the 1/2 x, and then 8 over 2 becomes 4. So let's try to find the inverses of the following functions. First thing we're going to do is we're going to swap the variables. Always do that first. Make sure that you swap. And now from here, you're going to solve for y. So to solve for y, I can't get rid of the square yet because I got to get rid of the 7. So this becomes x plus 7. Now from here, I got to get rid of the square. So I need to physically take the square root of both sides. Here's where you have to be careful. The moment you take the square root of both sides, it becomes a plus or minus. And then from here to solve for, now that the square and the square cancel, solve for y by just adding 3 to the end. You cannot add 3 to the 7 because that 7 is underneath the square root. And that becomes your answer. For g of x is literally the same thing as y. So you can still swap. So this is now going to become x. And this is now going to become a y. So that was the first thing that we did. X and y swap. And now we're going to solve. I first need to get rid of the 6. Now I got to get rid of the 4. And now I got to get rid of the square root, which means I need to square both sides. So this will give me x minus 6 over 4 squared equals 2y minus 5. I would not distribute the square because you'd have to FOIL the top, so I would leave it. Next, to solve for y, I'm going to add 5. And finally, divide by 2. All over 2. That is not very pretty. Okay, so I want you to attempt this one on your own and then resume the video to see the answer. Okay, so the first thing we're going to do is we are going to swap the variables. Okay, first thing, make sure you swap. Now I'm going to have to work from the outside in. So the first thing I do is get rid of the 3. So the opposite of a cube is a cube root. So I'll have the cube root of x equals 8 times 7 root y plus 1. Now I am going to solve by subtracting 1. So I have a cube root of x minus 1 equals 8 times the 7th root of y. So now from here, I can divide by 8. So I'll get the cube root of x minus 1 over 8 equals the 7th root of y. Now I can do the last thing, get rid of the 7th root by raising it to the 7th power. So my final answer would be the cube root of x minus 1 over 8 raised to the 7th. There's one other thing that you have to learn how to do, which is rational inverses. So first thing we're going to do is we are still going to switch. So this is now going to become x, and this is now going to become y. Here's where it gets interesting because you have them in multiple places. Every x has to be created as a y. So here's the first step that you're going to do. First thing you're going to do is you're actually going to make them a fraction and you're going to cross multiply. So I'm going to get x times y plus 4, and that is going to equal y. Now you're going to distribute xy plus 4x equals y. From here, you are going to get the y's together. So I'm going to subtract. So 4x is going to stay over here, and I'm going to subtract xy from here to here. This xy needs to come to this side. Okay? Now you are going to factor the y. You will always be able to do that. So you'll get 4x. I can factor out a y, and I'll be left with 1 minus x because I factored the whole y out, so I had a placeholder of a 1. And now solve for y. So now that means I can divide. So I'll get 4x over 1 minus x, and that equals y. Okay, now your turn. I would like for you to pause the video, attempt to find the inverse of this rational function, and then hit resume to see the answer. So first thing you are going to do is you are going to swap your x's and y's. So everywhere you see an x, you should make it a y, and everywhere you see a y, you should make it an x. And now you are going to cross multiply. So you are going to make everything a fraction and cross multiply, and you'll get x times y minus 5, and that'll equal 2y minus 1. Now you need to distribute. And now from here, you need to get the y's on the same side. So what I need to do is I need to get this y and this y on the same side. So when I do that, I am going to add 1 to this side. So it's going to be 1 minus 5x. And then I need to get the xy on that side. So I have to subtract it. So now they're on the same side. I got all of my numbers and variables on the left side. I got anything that had to do with the y on the right hand side. Now from here, now you will factor the y out, which you should always be able to do. So I'll get a y, and then when I factor the y, I'll get a 2 minus x. And now you'll solve for y. So I will be able to divide. So I'll have 1 minus 5x divided by 2 minus x, and that will get me my y. So something that happens with inverses that's kind of cool is that if you take the composition of a function and its inverse, you actually will get literally the variable x out. Everything else will completely go away. It will disappear, literally leaving you whatever the variable is that the function is about. So if this was like f of f inverse of like y, then y is going to be your answer. So I'm going to prove that f and g are inverses of each other. So you can do one of two things. There's two ways to prove it. You can either go ahead and actually find the inverse of f to see if it looks exactly like g, or we can take the composition. So the first thing I'll do is I'm actually going to take the composition. So I'm going to do f of g of x. So I'm going to take the outside of x. Okay, so that is my f function. And now I'm going to place all of g, which is the cube root of x minus 1 over 4 plus 5. And I'm going to place it inside here. So the cube root of x minus 1 over 4 and then plus 5. I have now placed it inside the entire function of g. I have placed inside f. Now let's start seeing what happens. Okay, well first on the inside, I have a 5 minus 5. That completely goes away, leaving me with the cube root of x minus 1 over 4. The 5's cancel. Oh. Okay. So I'm going to place the entire function of g into the value of x. So where you had x right here in the function, I have now placed the entire function of g. And now let's see what happens. Well, first I see a plus 5, and immediately that I see a minus 5, which means they are going to cancel. So I'm going to have a 4 parentheses. All right, I have a cube root of x minus 1 over 4. The 5 minus 5 cancel. Now I'm left with a cube as the exponent and then a plus 1. Okay, next thing I see is that I have a cube root and I have a cube that cancel. So I'm just going to bring down the 4. The cube root and cube cancel, leaving me what's underneath that cube root, which is x minus 1 over 4 and then plus 1. Next, I see that I have a 4 and a 4 that cancel. This 4 and this 4 divide out of each other. They cancel each other, leaving me just the numerator of x minus 1, and then I have a plus 1. And now x minus 1 and plus 1 cancel, leaving me just the variable of x. So everything basically offset each other throughout the problem when you do the order of operations, leaving you x. Same thing would have happened if I would have done g of f of x as well. So I have now proved that if you do one function of the inverse, or the composition of its inverse, you will literally get the variable x. So let's see if these two are inverses of each other. So we can do one of two things. We can actually find the inverses of each other, like we can do the composition and see if it is. And so let's attempt this. So the first thing I'm going to do is let's do f of g of x. So I'm going to take the entire function of g, which is x minus 4, and I'm going to plug it into f. So f is x squared plus 4. But instead of x, I'm going to put in x minus 4. And so now let's actually reduce this. Well, first, I see a square root and a square, they cancel, leaving me x minus 4 on the inside, and then I have a plus 4. And a negative 4 and plus 4 give me x. So that did work. And then we could do the same thing. I could have done g of f of x to where I will get, I will take the entire function of f, which is x squared plus 4, and I'm going to put it into g. So g is the square root of x minus 4, and x is x squared plus 4. So again, if I do it, if I start reducing, I have a plus 4 and a minus 4 that are on the inside. They cancel each other, leaving me x squared. And then from here, I have a square and a square root that will give me x. That is true. Here is the only thing that we want to note. If I was to take f of x and I was to find the inverse, I would get x equals y squared plus 4. I'll get x minus 4 equals y squared. But here is the only issue. When I get rid of a square, to officially get rid of the square, you got to take the square root of both sides. When you do that, you have learned in the past that you should get a plus or minus. So technically, if I was to take the inverse of this, I should get a plus and a minus of it. Now, if I was to put either the positive or the negative back in here, I would still get x. It does work. But what's happening is the square root of x to the x minus 4 is only half of this. So if you think of the fact that x squared plus 4 is a parabola that looks like this, the graph of x squared minus 4 starts at 4, but it's only the top half. Now, that is fine because technically if I was to do the full version of the inverse of this, technically it is supposed to be the parabola on its side, but that would give you something that's not a function because the vertical line test would fail. It would cross into places. And so the fact that this is just the positive version, which means that it does represent a function, it does work. But just be aware that if you're physically taking an inverse of something that has an even power, when you find the inverse, technically it needs to be a plus or minus. Now, there is also something that has to do with tables. We can do the exact same thing using a table. So what we're going to do is first do the inside. What we want to know if the inverse is of g of 18 is basically when does g equal 18 is basically what the inverse is asking. So if I find g of 18, that is right here, we are going to go in the opposite. We're going to do the opposite and find out what was the x value. X was 11. So now you're going to take 11 and you're going to plug it into f. So now I want to know what is f of 11. So here's f. F, when x is 11, f is 15. Okay, I would like for you to try these 4 problems. Pause the video and then hit resume to see the answers. So for the first one, I want to know first, what is f of negative 16? Not the inverse, but just strictly what is f of negative 16? So what I'm going to do is I'm going to go to negative 16 and I'm going to find what is f of negative 16, and it is negative 9. So now from there, I am now going to plug it in for g. So now I go to negative 9. All right, here's negative 9. And I want to know what is g, and it is 15. Okay, next, g of 3, and then I want to know f of g of 3. So first thing I'm going to do is start with the inside, g of 3. So I'm going to go where x is 3, and I'm going to find what is g. It is negative 9. And now I want to find what is f of negative 9. So now I'm going to go to negative 9, and I want to know what is f, and it is 12. Next, this is where I'm now doing the inverse. So I want to know, in this case, when does f equal 1? So I want to know, all right, so now I see where f equaled 1, so I got to work in reverse order, and that answer was 20. So now from that, I can now find g. So now I'm at 20, so now I'm going to say, okay, what is g at 20? And it is negative 1. And then last, I want to know when g equals negative 17. So here's g. I'm going to find negative 17. So I'm going to work in reverse order. And what does x equal? X equals 0. So now I'm going to be able to find f is 0. So here is 0. Now I want to know what is f, and it is negative 8. So last, to recap, let's find the inverses of these and determine if these inverses, if these are inverses of each other. So go ahead and pause the video, attempt these problems, and hit resume. So first, I am going to swap the x and y. Make sure you swap them first. And now I'm solving for y, which means I'm going to subtract 1. Now, I can't get rid of the 2 yet. I got to get rid of the 5, which means I am going to raise both sides to the 5th. So I have x minus 1 to the 5th equals y minus 2. And last, I'm going to add 2, and that will be my answer. On this next one, same thing. I am going to swap them first. Always swap first. Now solve. So I'm going to multiply both sides by 7. Now to get rid of a 1/3, I am going to raise both sides to the 3. So I'll get 7x to the 3rd equals y. And last, if I was to find the inverse of this, for example, if I say that this was f and this was g, I could do f of g of x to see if they offset each other. So I'm going to take f, which is x cubed minus 1, but instead of x, I'm actually going to put the entire function of g in there. And now let's see what happens. First, I have a cube root and a cube. They cancel, leaving me x plus 1, and then I have a minus 1, and 1 minus 1 gives me x, and so yes, they are inverses.